advice, right? And in learning anything, you really have to,
No problem.
yeah, you really
Thank
have
you
to
for the
be
advice. I
prof-
really appreciate
yeah, you're welcome. You're welcome. I
doing
really,
that.
yeah, thank you. Thank you. Versha, I want to hear
You're
from
welcome.
you.
Yeah, hello, can you
Versha, you
hear
want to
me?
say hello? Yeah, we can hear you. Good day.
Hi, good day, everybody. Well,
How is Brazil today?
it's fine here, thank you.
Yeah.
Well, it's more than 5 minutes. I think we should start, though there are very few people here today.
Cool. So we just want to keep get it started right away. Right. I'm really wondering, did we all get the link, like the notification for this meeting? So it will not it's I'm thinking, hope it's not an issue from our own end that people are not joining.
I don't think so because the link is on the WhatsApp group and it's directly from there I joined.
Line
Okay.
low. Open mode.
Okay, cool. No issue. So, like we did last week, we're just going to start up on that note again, where we want to welcome ourselves in our own local dialect, right? In our own local language. So, you want to tell us welcome in your own language, and please let us know the language and what country the language, yeah, what country speak the language. Right. So, yes, Kevin is reminding you to record the session, please.
Yeah, thank you.
Right, so
Ekabo,
let's welcome us. Oh, okay. Cool. What language, country?
this is Ayodele, the south of Nigeria,
Oh, interesting. Nigeria. Thank you very much,
the
Ayomide. Yes,
southwest
who
part
else
of
wants to
Nigeria.
go?
Ekabo
Southwest
Yetuwa.
Nigeria. Oh, okay.
Yes.
Thank you very much, Ayomide. Yes, who else? We need like two more responses, then we commence.
Karibuni sana from Kenya, Swahili.
Swahili. What did you say again? What's the word?
Karibuni, karibu,
Karibuni, karibu. Swahili.
karibu.
Interesting.
Yes, yes, yes.
Cool. Yeah, so Jimmy, you want to say something? Oh, okay. I can say Asante Sana. Cool. Kobe, thank you very much. All right. So we just want to get started today with the session. Let me just stop sharing this because basically we're going to have fully hands-on session today, and there's really no major slide to prepare. However, I might need to work with a board, a whiteboard. So let me just see how that would work and then move immediately. Yeah, so Mr. Sam shared with us earlier today some links that we should go through to read off some things, which is where we want to kick it off this very evening. Yep. So I'm just going to get started with it. Sorry.
Hi, Josh.
Yes.
Good.
All right. Right. So we want to start today with talking about some metrics in machine learning, deep learning, which you want to call it. As Mr. Stam rightly explained to us last week, right? Deep learning is not really does not need from last week's session. How that you really don't need to understand the math that is going on behind the scene of the model you're building. Right? You only need to know how to use the model which already have the mathematics embedded in them. Do you understand? And so that's where we want to pick it off this very day. Right. So I'm just going to start off with some deep learning metrics. Now, so when we talk about metrics, it's a way that we data scientists, machine learning engineers, right, use to measure how good a model is. Right? It's used to measure the performance. Yeah, exactly, the performance of the model that you have just built. And I'm going to give a very good example here. However, in machine learning, right, we have supervised, right, and then we have unsupervised.
Hi, Josh. The,
Right
the
now.
gem board is not sharing. It's not showing.
Oh, the Jamboard is not showing.
Uh, n-
Oh,
Not live.
pardon me, please. Oh. Sorry about that. I guess you should be able to see it now, right?
Yes. Okay,
Oh,
now.
okay, cool. Thank you very much for that. Thank you very much for that. Okay, so I'm talking about in machine learning, right? We have basically fundamental, even though we know we have the reinforcement, right? We have supervised learning and then unsupervised learning. Now, the major difference is that for supervised learning, there is always a target data, right? A target variable where you want to, this is what you call that, this is where you are targeting, right? Like we have a linear regression, and then we have also the classification, the what looks quite back, right? So, so as I was saying, machine learning, we have unsupervised, then we have supervised. Remember, we are going to metrics for measuring the how best our model performs. And these are very important foundational knowledge we have to get concerning all this. Now, the unsupervised is basically divided into two, right? We have linear regression, and then we have classification. For this classification, right, what happens is that you have, take for example, you have an insurance data, right, that wants to help you to predict whether based on some particular metrics of someone that is trying to buy an insurance, right, whether he will be able to claim the insurance or not. Another example, say you have a test score and you want to be able to classify whether based on this test score the student passed or not, right? Another example, say you have images of different flower and you want to classify probably based on some metrics like maybe the petal length or whatever. I'm really not good in biology, so you want to classify whether this particular flower it belongs to this class of flower or another class. Do we get that? That's this classification part. For linear regression is quite simple. You want to predict. You want to predict what would happen in the nearest based on this data, right? You want to predict what the outcome will be. And that's why these two actually have a target variable. However, for unsupervised, there is no target variable, right? You just want to classify, sorry, you want to group them. It's called clustering, right? Like you use it to make recommender systems, right? That's what YouTube use to recommend movies for you. That's what Bill Player uses to recommend music for you. That's what Facebook uses to recommend threads for you to read. Right. So now, what happens when we build? I'll try as much as possible to be fast. When we build this, someone is trying to come in. Okay. So when we build this model, I'm picking classification now. So we have, it's possible we have basically two types, right? Binary, I will explain, and then multi. Now, for binary, we're talking about two, binary two. So your response variable in this binary is say yes or no, zero or one, good or bad. A very good example is what our mail, right? Our mail providers, software as a service providers, use to classify whether a particular mail you receive would fall into your inbox or as a spam. Do we understand that? So I'm trying to give us a very live practice or operation of all of these algorithms, right? So this binary system is just you want to say yes or no, two possible outcomes, two possible answers, two possible target variables, whether the insurance will be claimed yes or not. And similar to that is binary. Now, binary, the multi. Now, multi is that you have more than one. Like you want to classify the color, you want to classify class, you want to classify the language a particular tweet was written in. You understand? That's multi. So let's get started with the metric. So I'm narrowing it down to binary and then use binary to build up to also explain multi. But once we understand the concept behind binary, I'll try as much as possible not to talk mathematics. Rather, I'll explain the application of the mathematics which you as a machine learning engineer, which I as a machine learning engineer needs to understand. Right? We really don't. When we build our model, so like I said, it's either zero or one. Target variable, that's what makes it binary. Zero. So I have a model. Let me bring up the model that will come up with it now. Okay, so I have the data that wants to classify whether based on other variables, right? Other variables, this particular data would actually be given an insurance, right? The possible answer is yes or no. So I want to take zero as no, right? And I want to take yes as one, right? Cool. So remember, these are what I'm trying to classify the other given data into. Now, I don't know if you actually have understood the trend test bit, but let me not just go there. Let me just focus on this one bit. So when we have no yes, zero no, right? One yes, I built a model. I got a make I split the model using the train test split from sklearn, right? So once I split this using, say I'm giving it a metric of 0.3, what that means is that I want to use 70%, which is 0.7 of the whole data set to train the model. Then I want to withhold 3 of this model, sorry, 3%, 30%, 0.3 of the whole data set. I want to withhold it to use it to test, to use it to evaluate the performance of that model that I am building. Right. So I've trained the model, right? I've given it all the metrics I need to use. I've tuned it and everything. I came up with zero. So I'm having, remember I said, please, I just want us to follow, right? Remember I said that based on this, we want to predict whether it is zero or yes, and we already split the data. That means we already know the target variable of that 0.3 that we are taking out. Right, so I want to use that because I didn't know the outcome. I want to use that to measure how best the model I've just built performed. Do we get that now? Um, um, so let's say that I've built the model. right? And then I want to begin to evaluate, which is where we are really going to now. I want to begin to evaluate how the model performs. So what I'm just going to do is the target variable that I already know. Remember, I withheld this from the machine. I didn't expose this to the machine because I want to use it to test the machine. So that one that I withheld, right? I'm going to call it the ground value. Um, ground truth value. This is the value that I already know from the data set, but I withheld it from the machine because I want to use it to judge how best the machine performs. Right? So then I want to now feed the other part. You know, we withheld 0.3. I want to feed the 0.3 part into the machine without this ground truth value to get the prediction out of it. To get the prediction out of it. So once I do this, I'm now going to compare the outcome from this prediction with the already ground truth value that we know. Let me have a clearer screen now. So this is actually, and that's the more reason why we need to take it. It's called the confusion matrix. It will give us a confusion matrix. Now, what the confusion matrix want to help us to do is it want to compare, right, how confused the machine is. Quite a good name, right? So let's have pardon me, let's have the ground truth value. Let's call it GT here. Right. So remember I said it's a binary, so we only have 0 and 1. So I'm going to call this now. Above here, I want to have remember I said that this prediction is that I want to get after I fed the part of the data that I withheld from the computer, from the machine. After I fed it into the model, right? I want to see what the outcome would be, then compare it with this truth value. Do we get that now? So for this prediction, of course, it's also a binary classification. So we are also going to have 0 and 1. Maybe it's not the best you are seeing. I just feel we could use this. Now, let me now explain this. Let me see if to change this color. Interesting. You see this ground truth 0, right? For this part here, this part of the matrix that we are looking at here, this column is actually the prediction of the machine model that you have built, while this row is actually the ground truth that you already know, which you withheld from the machine when you were training the machine. Now what happens is that after this prediction, of course it will only have possible zeros and ones, right? So let's assume it's this particular column, right, it actually predicted it to be 0 and it was actually 0. Do we get that? So that means it's true, right? So I can call this for nomenclature's sake. Let's call this truth. Let's call this false. Let's call this truth. Which I actually can do true 0, right? I can also do true 1 here, but let me not do true 1 because I'm trying as much as possible to break this down to the various minimal level of understanding. So just understand the logic. This particular cell here, right, will be for, yes, it is actually the machine predicted it to be 0 and it's actually 0. So that means we call it, let me call it true not, right? Now, for this particular column, right, the machine predicted it to be 1, whereas it's 0, right? So I'm going to call it false 1. That means The machine predicted it to be one, whereas it's false. So that's why I have F1 here. Now, for this other cell, right, we have the machine predicting it as zero, whereas it is one. Are we going together? Just want
Yes.
to check this.
Yes.
Okay, thank you. Are you getting the explanation, please?
Mas hoje você vai ter que cobrar por
Yes.
ter um motorista internacional.
Yes. Thank you. Thank you. So you see this part now, this column here, and which is quite important. I use this board because there's no way I could have said all this without you getting the visual. So this particular column now, right, is the machine predicted it to be zero, whereas the truth value, the ground truth value that I already know says it is one. The
Eu
machine
passei a manhã toda preparando algo, aula, sua merda.
prediction is false. So what's the prediction value? False, zero. Do you get? So what would this part be? The machine predicted it as one, right? Whereas it is also one. So this is actually true one. Do I need to go over that again? Please let me know. Hello? Hello?
I'm good.
Okay, cool. So um let me quickly go over this again. Right? This is called a confusion matrix. This is the prediction from the machine. This is the ground truth. How did you get this ground truth from? From the data that you withheld from the machine when you were training the model. Do you understand? Because it's always important to evaluate. You don't just want to use 100% of your data to train the machine, and then there's no way you could evaluate how the model that you just trained performs. We get that. So on above here, which let me just clear this and maybe come up with a better result. So we still have the prediction up here. Let me change the in. We still have the prediction up here, right? We still have the ground truth value at this side here, right? So let's assume it's actually true false. We are looking at now. Let's assume it is positive negative, right? Positive negative. Remember I said it's binary, right? Binary. So that means it's only two values possible that we can have. Let's also assume this is also positive, right? And then this is negative. Right. So for this part, this is the prediction from the model now. This part. Let me change my in. This is the prediction from the model, right? This is the value I already know. So the model predicted it as positive and it is actually positive. It's going to fall here. That's true positive TP, which is what we must have been seeing almost everywhere. You see TP, TL, FE, FM, right? It's just to understand that there's really no hard and fast rule here if you understand the principle going on behind the scene, right? So the prediction was positive and it's actually positive, so it is truly positive. Do you get that now? The prediction, the machine actually gave it as negative, predicted negative, whereas it is positive, right? So it is actually sorry about that. So it is actually going to be a false, right? Because it is false. That's why it's carrying a false here. A false negative. Do you get that now? Down here, this particular cell. The machine predicted it to be positive, whereas it is negative. That is false, right? So what would now false positive? The positive will take the value of the prediction, not your ground truth. So then down here, it's actually negative, right? And the machine actually predicted it as negative, and it's truly negative. So it's going to be, it is true, and that is it's negative. So based on this, you see this simple confusion matrix you just seen here, right? I hope it doesn't actually get you confused eventually. right? But on this actually stands the major metric that is used to measure the performance of the classification model. Based on this now, we now have what's called accuracy. Let me clear this. We have accuracy. I'm rounding off soon so we can get on the live session. Even though I'd love to show, because I was actually writing building a model yesterday where I used these metrics, but even though that one is for a multi-class, right? So the way the multi-class behaves is that it takes each of the class binary at a time. So take for example, I'm coming, just hold on with this. Let's assume we have three classes we want to classify into, right? So it takes one of the class as true, then the other two, right, as one. So you having eventually you're having two. So you run the same what's it called confusion matrix for this. Let's say you have big, medium, small, right? Yes, very good. Big, medium, small, just like my three fingers. Big, medium, small, just classify into these sizes, right? So to run the same confusion matrix for this, you are going to assume that it is actually you take the small one first, then consider this as one. So you are saying, is this small? If yes, that's one. If no, whether it's medium or big, I care less, it is false. Do you get that now? Then you're now going to hold the next two again like this, right? And then so you are saying, is it big? If yes, it goes this way. If no, whether small or medium, I'm less concerned, it goes this other way. Did you get that? Then you're now also going to do the same thing for the medium. Is it medium? Yes, it goes this way. Whether medium or not, whether small rather or big, I care less, it goes this way. So basically, that's why if you understand the binary classification, the binary, yes, binary classification, it's the same method that was built on to get the multi-class code. So let's just continue. So based on the confusion matrix, right, we have what's called accuracy, we have precision, then we have interesting. So all of these three are actually built from the confusion matrix. Let me just do a demo confusion matrix here. Very easy. Let me just admit this first. So let's say we have this is actually true positive, this is true negative, this is positive negative, so this is false negative, this is false positive, right? So what this accuracy actually means, and that's why you need to understand where each of these metrics come in place. And I'm actually taking too much time. I would just want to end it here so we can get, because the main focus for this session is the hands-on class, which I would not want to take the whole time, so we can have online class free. But you need to understand the application for each of these three metrics that we have. The accuracy is just a measure of um, so we have
Hi, Josh. Are you there?
hello.
Hi, Josh. Are you there?
Yeah, can you hear me now?
Yes.
Yeah, now we can hear.
Oh, sorry, it's actually cloudy. It's about to rain here, so I guess the connection will now begin to fluctuate. So let me just quickly bring this to a close. So, what this I'm talking about, let me clear this. I'm talking about accuracy, right? What accuracy wants to do for you is that it wants to measure how many times, right, your model actually predicted true values. We have true positive, we have true negative, we have false positive, we have false negative. So what this accuracy wants to do is that it wants to measure how many times was this model actually correct by predicting true, by predicting positive when it's actually positive, and negative when it's actually negative. Do you get that now? So you really want to, while on the other hand, right, what the precision does, precision, precision is more concerned about how many times it was able to predict only true positive. Do you get that? So precision is more particular about the positive time, the true positive time, positive, positive. Accuracy is also a measure of true, it cuts across both positive and negative, right? And that's why it measures, I don't want to do the mathematics here, right? Let me just admit this person, sorry. So let me not go into the boring mathematics, but just understand that accuracy, right, is for each of these, whether truth or whether true positive or true negative. And precision, on the other hand, right, is only particular about how many times it was able to predict truth positive, right, without taking into consideration the negative, like that's what's it called, true positive, right, will have false negative and false positive. So it's only about positive, particular about positive, right. Why finally, recall, don't worry, as we continue, why for precision, did I say precision? For recall is quite similar to precision, only that this one is positive, is concerned about the true positive, right? And how many times it able to predict this true positive. So that means how many times it predicted negative, whereas it was positive. So that's what makes it false here. How many times you predicted positive, right? Positive, and it's truly positive, which is TP. How many times you predicted negative, whereas it's actually positive? That's what this report metric does. So understanding where each of these metrics come in place, there's really no hard and fast rule to selecting which best to use. It's based on the particular problem you're trying to solve that will determine the best evaluation metric that you are going to use. And at this juncture, I need to get a glass of water. Please, Mr. Sam, if you're ready for us, you can have the floor now as you take us through the next session. I do just hope, I majored more on that of distributed reasoning because we are getting to logistic, sorry, did I say logistic? Linear regression models also. That's when you get to predictions. Right. Thank you very much.
Thank you, Josh.
Okay.
Thank you
Mrs.
very
Sam,
much.
you have the floor.
Okay, thank you. Okay, now that was about accuracy. And as Varsha asked, accuracy may be used for both supervised and unsupervised training models. However, it is usually more used with supervised models. Okay, and that is very important. Along with the explanation that Josh just gave us, please make sure you read the articles we shared this morning. You have further information there. It is very, very important for you to understand these kinds of metrics. Along with accuracy, we also need to know that there are many other metrics. I'm going to talk about mean, sorry. I'm going to talk about errors, how we calculate how much our model is making mistakes, or the loss percentage in our in our model. So I'm not gonna go deeper. You have lots of article articles in the internet. You can read on that. You just need to understand that every machine learning model has loss. It means they are not 100% precise. They make mistakes, just like, not exactly like human. They make mistakes much less than human people, but they also make mistakes. And that's what we want to understand. When we're talking about accuracy, we are trying to understand how good or how bad our model is. For example, if we predict 10 times, how many times would it predict it correctly? Or how many times would it possibly predict incorrectly? That's what we're trying to measure with accuracy. Loss function, it's just about the same. It is just another way to calculate, to measure the loss that we have as we compute every training session. That's particular is. So now let's go to some practice, okay? From now on, I'd appreciate I'd appreciate you can have um, Google Colab open so that you can follow along with me. Okay, from now on, we're gonna have some hands-on. Just give me a second. Just one more second. I'm gonna. Oh, in fact, I have two. Okay. Let me share my screen. Where am I? Here. Can you see my screen?
Yes, please.
Okay. So, okay, good. So from now on, please go to Google Colab. You can go to it. You can just go to it using this link. So let me share it with you. Okay, so go to Google Colab, please. Oh, let me get the right window. This one. Okay, I cannot see the window. What can you see on my window? Can you say what I have just written?
Yes,
What have I written?
I Josh.
Oh, good. You see the right window. Thank you. Okay, to start with, I hope you have the window opened. Let's start let's start by importing. In fact, what we're gonna say is, okay, so let's start by importing carers. So let's say that oh gosh, from TensorFlow import carers, and let's run it. You all know that TensorFlow is our machine deep learning framework, right? And what is Keras? Who remembers what Keras is? From last week's session, what is Keras?
It's library for neural.
TensorFlow indeed is a library, and Keras is, how do we call Keras? Keras is an API. Remember? Keras is an API, it is an application programming interface that help us work with TensorFlow. Okay, so the main library indeed is TensorFlow, but instead of working directly with TensorFlow, most of the times, since TensorFlow version 2.2.0, we are using Keras as an interface to work with TensorFlow. So from TensorFlow, I want to import Keras. I also want to import our TensorFlow as well. So let's say import TensorFlow as TF. TF is a nickname, an alias, right? Additionally, let's see what TensorFlow version we have. We can see that with print TF dot underscore underscore TF dot underscore underscore version underscore underscore. So we are working with TensorFlow version 2.8.2. That's okay. And now we are also going to import NumPy. NumPy stands for Numerical Python. It is a library that helps us work with mathematics and mathematics transformation, right? Let's call it NP. So let's import NumPy as NP. And next, we need to import a library that will help us do something. And you, please, matplotlib, matplotlib, matplotlib dot pyplot splt. Sorry, splt. Okay, guys, what does this library do? Matplotlib, pyplot.
Graphs.
Yes, it will help us work both with graphs and also with images in general. Okay, good. So we have imported matplotlib.pyplot splt. That's okay. And now what we're gonna do is uh, we're gonna import a library we are going to import a data set that is called fashion eminist. And for that we're gonna say feminist. We're gonna create a variable called feminist, fashion eminist. It is this library, it is in keras dot datasets dot fashion underline eminist. So when we do this, something wrong here. Keras dot datasets dot fashion double N eminist. That's it. Okay, here it is. So we have just created, instantiated the fashion eminist data set, and in this data set there are lots of information about fashion articles, and we are going to create a model that will be able to recognize what type of article an image is. But before we do that, we need to split this data set in four parts. So we're going to split that in training images and also training labels. Additionally, we're gonna split it into test images and test labels. So let me just see test images and test labels. That's okay. So we're gonna split that, and that is gonna come from where? It's gonna come from the fmnist variable that we have just created. So let's run it. Something fmnist. Oh, sorry, fmnist. I forgot to load the data. Load data. Sorry. That's it. So let me share that with you. Okay, now we have loaded our fashion data set, and we have split it into four portions, into four parts. We have split it into training images and training labels, and also with test images and test labels. But again, what do we have in this data set? Can anyone just remind me what we have in this data set? No one remembers? What are we gonna find in this data set?
I think it's picture of it's images,
Oh, that's
images
right.
of dogs. Cats.
That we're gonna find in this data set pictures of images. And to show those pictures of images, let's do one thing. Let's use pyplot. So let's say we call pyplot as plt. So let's say plt dot x label, and let's call this x label, well, I don't know what we're gonna see. Let's say just something. Additionally, oh, sorry. Additionally, let's say plt dot image show. Let's take an image from the training data set. So let's take an image from the training data set. Let's take the first image from the training data set. Oh, here it is. It is, well, it's probably an ankle boot, I don't know. So let's see what this picture is. So the picture information is stored in the training image. So the first one that starts with, the first one that starts with 0 is this image. Let's see what it is. The training label, the one that says what indeed this one is, let's see if we can have it here. Let's see what training label 0 is. Let's run it again. Oh, it is an item number 9. But what does an item number 9 is? Well, to know that, we need to learn a little bit more about our data set. And I will show you in just a second. Just give me a minute. Let's see the labels, I mean the information we have here. I will show in a second. Okay, so the kind of information we have there, let me just copy and paste here to make it faster. We have 10 different information in this data set. So I'm gonna create a list. I'm gonna create a list. I'm gonna call this list my images. And in this list, we have all of these items. We have item 0 is a t-shirt top. Item number 1, trousers. Pullover number 3, dress 4, coat 5, sandal 6, shirt 7, sneaker 8, bag. Oh, something wrong. It should be from 0. 0, 1, 2, 3, 4, 5, 6 is a shirt, 7 is a sneaker, 8 is a bag, and 9 is an ankle boot. So this is what our list of fashion items look like. We have 9 different types of fashion items, okay? So, okay, now that we have created a list with all the names of our fashion items, what else can we do? Let's see another item. Let's see item number 1. What do we have here? Let's run it again. And for item number 1, we have item 0. Can anyone tell me what item 0 is according to our list?
T-shirt.
It is a t-shirt.
T-shirt or top.
Good. T-shirt or top. Good. Let's try and see another image. Let's say I want to see image number, I want to see image number 1, 2, 3 and see what it is. Can anyone tell me what this one is?
Pullover.
It is a pullover, right? Okay, so remember from last class that we had two lists, one with the number of rooms and another with the price of the apartment. What we're gonna do here right now, it is just about the same. We have a list with the fashion item, and we have another list with the label where we have from 1 to 9 that tell us what that fashion item is. Okay, so what we're gonna do, we're gonna create a model that will try to understand the relationship between the training label and the training image and the training label. It is gonna compare and it's gonna make a mathematical model that will try to be as good as possible in classifying what kind of image is. And to do that, we split our model in two. We split it in training images, the one that we're going to use to train our model, and another one with test images, images that our model has never seen, and we're going to use it to see how good our model is. But before we go on, I want to know how many items we have in the training images. Can anyone help me with a function, a Python function to do that? How can I know how long this training images list is?
Use
By checking
len.
with len.
Use len.
Okay,
Len.
so okay, so let's say land training image. Oh God, we have 600,000 images in the training images. Let's see how many labels we have for training labels indeed. training labels. Oh, what is the name? Oh, sorry, I forgot. Name. Training, train. Again, we have 6,000 training labels. That's okay. Next, we need to see how many items we have in the training, not in the training, but in the test images. Again, let's use LAN. So test, LAN test image. We have 10,000 images in the test image. Can anyone let me know how many test labels we have? We probably have. Before I hit run, can anyone guess how many labels we have? We had 6,000 training images and the very same number for training labels. If we have 10,000 images, test images, how many test labels should we have? Any guess?
10,000.
10,000.
Yeah, it should be the very same 10,000, right? So here it is, 10,000. And so it is, as we had some homework that was very important to show the images. We are using matplotlib.pyplot as PLT. So we have imported it, and we just say, hey, show me, hey, use this X training label and show me the item number 123, and that's what it does. PLT dot image show, and it will show whatever we want. Okay, so let's see that we want to see more and more items. How can we do that using random numbers? We can do that by creating a random number. So let's say my random item equals NP. NP stands for what?
Number.
NumPy, right? So I'm using NumPy to generate. Oh, sorry. I'm using NumPy to generate 100 random number, and I'm gonna record that information in a variable that I just called my random item. So let's see what this random item is. This first random item is. Oh, we can do like this. Good. The first random item I created was number 46. Every time I hit, it will bring me a different number. So that's good. That's what we want. And to make things even easier, let's create a plt dot x label. What does this function do, boys and girls? Can anyone tell me?
Whatever random number is chosen, it will put in that plot.
Okay, good. So let's say like this, test labels, my random item. So we are gonna generate a random item, and I'm gonna use it as the label for our image. Next, we're gonna show it. We're gonna show an image indeed. Plt dot en show image show. Let's call it from test images. What number? Well, let's use the random number we have just created. So my random item. So let's run it. Here it is. So every time I hit it, I execute it. Oh, not every time I need to run the random number altogether. So let me do it here. Okay, so every time we're gonna see a different item. A sneaker again, a bag, a t-shirt. And I have a question for you guys. Do you think that if I hit this 100 times or even 1,000 times, the image, once I have trained my model, the image that we are gonna have will match with the label? If I do that 100 times or 1,000 times?
No, I don't think so because what we are testing is to test the accuracy of our model. So sometimes it may fail not showing not matching the label with the image.
Can you explain that, why that happens?
What I think is, since the model cannot be 100% accurate, so we may be adding such.
That's right. So hardly ever will we find a model that is 100% accurate. So note that even if it is an artificial intelligence, hardly ever will it be 100% correct. So be prepared that in some cases our machine model will fail because we will never or hardly ever get to 100% of accuracy. And whenever we do that, we probably have some kind of overfitting. Our model has learned too much and it's not working correctly. Okay? Thank you very much. Have you followed me? Is anyone using Collab now and following me right now?
Yes, I'm listening with thoughts. I've get based. I've
Okay.
missed some part.
Sorry, are you using Collab now? Are you following all the instructions?
Yes.
Oh, good. Very good. Good.
Sorry, son. Just to be sure that others are also following us. Maybe.
Cell battery, please charge.
I had a problem, guys, here. Just give me a second.
99.
Hello, can you hear me now? Oh, good. Okay, so let's
Yes,
go ahead.
please. We can hear you loud and
So
clear.
now, boys, do you think How do you think that this image is stored in our system? Is that an image? Do you think it is an image? How do you think this image is stored? Is it a JPEG file? Is it in Paint file? How do you think it is stored? I'm gonna show you. This is what you see, and this is what it is recorded in our system. Just some numbers. Whatever you think in a computer, they are nothing more than numbers. So you see a picture, but the system is stored it as a number. Okay?
No,
Did you understand that, guys?
Sorry,
No
Mr.
problem,
Sam,
please.
just sorry to interrupt you. Yes, please. So I'm saying that to foster every one of us following with you, could you please help paste the codes as you're
Oh,
writing them
sure.
on the chat like you did last week? If that would help.
So
Thank you.
let me do like this. Just a few lines. So where's the chart? So from the beginning, so this is number one, two, three, four, five. I could have shared the notebook with you, but again, it is important that you type, that you understand line by line what you do. Finished. Good. So again, can anybody tell me what you see in this screen now? What do those numbers mean? Anyone there? Are you there, Josh? Can you hear me?
Yeah, I can hear you. I'm only trying
Okay.
not to answer questions to be sure that are following us too.
So we are trying to also test it on our collab too. We are trying to test the code and try to copy the code and test. You can see is as being said earlier that these are numbers representing
Right.
pictures
Okay, good.
of
So
those
it
images we
is
are
an
receiving.
array that represents an image. This array represents this image. So, I mean, this is a new image. Let's see what number it is. Oh, let's see the item. Let me print the print. Okay, so for this image, this is the corresponding array that represents this image. If I run it again, if I run it again, I have a new image. Therefore, we're gonna have a new array. And every picture is indeed an array of numbers, an integer, not in fact a float array with lots of numbers that compose an image. Is that clear to you guys? Please let me know. Hello? Anyone there? Okay.
Yes, it's clear, sir.
So, can anyone tell me how our data model was split and why we need to split a data model?
so that we
Yes,
can test it. We can test it with some data which our
perfect. Who
model
was that?
has
Was that
not
Varsha?
seen.
Oh, thank you, Varsha. Yes. So whenever we have
Yes.
a data set, we need to split it, and we're going to use a percentage of that data to train our model, and a small percentage to test it, to try to evaluate our model, how good it is in guessing, in predicting the right information. Okay, and always remember, although we can see pictures for a computer, we always have numbers. Although we can see letters for a computer, there is nothing but numbers. Okay? And we have split it, I'm just reviewing this. We have created a variable called fmnist. It got the information from the keras dataset.fashion fmnist. Then we load this information and divided it into training images and training labels, test images and test labels. Now we are visualizing these images, trying to understand and to know how many items we have. We can use the len training images, len training labels. We can use pyplot to plot the images, and from now on, that's enough with theory. Let's start creating our model. But before we create our model, again, let me show you what indeed we are going to do. We are going to try It is just like a linear regression. It is very similar to a linear regression. We have one line, and we're going to call this line training images, and we are going to try to fit the training images to the training labels. And once we train our model, we fit the images to the training labels. That means that we are training our model on how to recognize each item. This is all about machine learning. And to do that, we need to first, now that we have loaded loaded our now that we have loaded our data set, let's now create our model creation. And it's very important you understand. In a model creation, the very first thing that we do is create the model. So let's create our model. To create our model, I'm gonna call it my model. I could call it Varsha, I could call it Josh, I could call it John. I'm gonna call it my model in this case. So it is something, a variable that I name the way I want. So I'm gonna create a variable. I'm gonna call it my model, and it's gonna take from the keras dot models dot sequential some layers, and I will tell you what layers are. Okay, so please follow along with me. So we're gonna create the first layer. It's gonna be keras dot layers dot flatten, and I will explain it to you in a minute. And in the first layer, what we're gonna do is we're gonna take those 100, 600 indeed. We're gonna take those 600 uh, image array, and when we have colors in an image, we have a three-dimension array. We have a dimension that is the length, we have a dimension that is the height, and we have a third dimension that is the color. That is the way the computer stores the information about each uh, image file. So for each image file, the computer will have three information: the length, what we have in the length, what we have in the height, and what we have in the color. So it is a three-dimension array. However, when we create our model, the first thing that we need to do is flatten those three dimensions. And you can think of, let's say that we have, oh, Josh, can you share with me that, oh, that board, this one. Can you, let's see if I can write here.
Which
Can
is
you
that?
see the board now that you were using, Josh? It, I mean, can everybody see
No,
it?
I can't see it yet. You want to use the board? Should I start one?
So
We
let's,
are only seeing your screen that you're sharing.
uh, yeah, give me a second.
We
I
are only seeing your
will.
screen that you're sharing.
Can you see the board, the gem board now? Not yet. Okay, give me a second.
No, not yet.
Give me just 1 second. So many windows. This one. Can you see the Jamboard now? Okay, so
Yes, please.
uh, okay, so when we have an image, we have one, we have the length of it, we have the height, and we have a third dimension that is the color. So how can I show you that? Oh gosh. Well, I hope you understand it. Let me make it up a little better. So we have the length, we have the height, and we have a third dimension. Let me write it in a different color. Okay. Then we have a third dimension that is the color. So all of these information are height, then we have length, length, then we have
length,
color,
and the color dimension.
then we have color. So this is what we call a three-dimension array. And in a three-dimension array, we would have some lots of number here. We would have lots of numbers here, lots of number representing this, and lots of number representing this. It is a three-dimension array. And in order to our model work well, we need to make the first dimension like this, the color dimension like this. Then we need to get the height dimension like this and the length dimension like this. This is what we call flatten. We flatten the three dimension in a single one dimension. Is that clear for you guys? Now, if not, please let me know. So remember,
Yes,
when
it's
we
clear.
create our model, one of the first thing we do is we need to flatten the 3D dimension. If we are working with images, we need to flatten that array so that it is a one dimension array. From now on, as we create our model, as we start training our model, that three-dimension array is gonna be a one-dimension array as soon as we write flatten. So let me go back to the other session. Okay, so this is what we do here in this. Oh, give me one more second. One more second. Give me just one more second. Can you what can you see in my screen now?
Your
Google Colab.
notebook,
Okay.
your Google Colab notebook.
The notebook.
Just one more second. Sorry, I have lots of windows open and I cannot manage them. something. This is nothing. Just one more second. Okay, can you see model creation now? Good. So we're gonna create a model. I'm
Yes.
gonna
On
call
your
it my
screen,
model.
yes.
To do that, we call carers.models.sequential because it is a sequential model. That's why we call it deep learning because we're gonna have many different layers to train our model. Okay. So the first model we need is the flattened model, and this layer, this layer has no parameter. Okay, then we are going to add another layer. So we say carers dot layers dot dense. A dense layer is a layer that will take the first information in our model. We have flattened it, and then we're gonna stack that first flattened layer to our model. And then the second layer, in this case, we're gonna call it a dense layer. We can give it a number. We should give it a number indeed. So in this layer, I'm gonna have 512 neurons. We're gonna call that neurons. Okay. It is like the number of information from the array that I'm gonna input in this layer. So we're gonna have it with I have used 512. It could be any other number. Okay. So let's start with 512, and we're also gonna need an activation function. I will explain it later. And this activation function, I'm gonna use ReLU. I will explain that later. We do need to understand what this means. As it is an intermediate layer, we're gonna use ReLU. As our final layer, let's call carers.layers dot. It is also gonna be a dense layer. However, as we have, as this is the output layer, see, our model has only three layers. A flattened layer, I have just explained. The second layer, which the machine will try to create a model like a linear regression and try to understand it. And then it is going to output the result of all this compilation to an output layer. And in this output layer, as we have 10 different items, so any fashion item should match one, precisely match, or probabilistically match just one item. So the output layer will be 10 10 neurons long, and the activation function, this is very important, the final activation function, as they are more, it is not a binary, it is a multi-binary function. We're going to use an activation function called softmax. I will explain this in the next lesson. You will read it indeed, and then I will explain it. And then we have created our first model. Let me compile it. Something got wrong. Activation, sorry. Activation. I always write this wrong.
Then the third one too, layers. Layer is not correct. In the third line. Is that how I'm going to study layer?
Let me try it again. There's also something wrong here. Activation. Oh, layers.
Layer,
Okay.
layer.
Oh, finally. So, guys, what we have created here, we have created our second deep learning neural network. We have created a neural network with three layers. And I wish somebody could explain again everything you'd have here. Can anyone tell me what is a flattened layer, the second dense layer, the first dense layer, and the third dense layer? Could anybody just, with your own words, and no problem if you make any mistake? Any volunteer? Who's that? I cannot see.
Can I go on, sir?
Sure, please.
Please.
I am here.
I am ready.
So as I've said, the first layer is where we are going to flatten the three dimensions, the height, the length, and the color, which will take no, it's not going to take any parameters. Then we have the second layer, which is the where we are going to actually run, which is going to be a very deep layer. So that one have a parameter of 512, where the activation will be on ReLU, which is what you're going to explain later. And the third layer, which is the output layer, so that we are going to bring out the result of the layers that actually perform the second layer that perform the testing. So it's going to be the, so we're going to make use of activation, which is called sort mass. So that will be the output layer. That's the
That's
third
it.
layer, which
Fantastic.
have a
Thank you very
parameter of 10.
much. And see, guys, this is why we call it a deep neural network. It is deep because it has more than one layer. In this case, there are three layers. In a future model, we're gonna have more than three layers as we grow, as we understand more and more. We're gonna add some more layers, and the more layers we add, the more accurate our model will be. So with just two dense layers, probably we're gonna get about, let's say, I don't know, about 79, 80% accuracy. As we add more layers, our neural networks will work more and will probably get even smarter and have a higher accuracy. So the first thing we do in a neural network is create the model. Once we have created the model, we need to compile. We need to compile the model. And to compile a model, it is very simple. We take my model we have just created. Oh, let me share this with you.
Sorry, why are you doing the sharing, Mr. Sam? Just to get feedback to ensure others are following us. Rasha, what's the progress from your end? I know Tony said he will get on it later, that
Sorry,
he's
Josh.
connected with his phone now.
Please,
So,
yes.
does anyone want to share progress? Yes? Just to be sure others are following, because it's like it's Ayomide that has been actively following us all along. Alice, Kevin, Fato, anyone?
Yes, I've also been
Rasha?
following.
I've been following. I think we are now at after you've just created the model, the three layers. Yes, I'm also.
Awesome. Are you also running it locally?
I was actually trying to run it, but I realized that I can't copy the code from my phone to because I'm using my phone to follow the session and
Oh,
using the
oh,
laptop so that I don't switch the screens. So I
oh,
can't
okay.
copy the code from the chat to the laptop, but I'll follow it later.
Okay then. Okay then. All right. You might want to continue then. Thank you very much.
Yes, are you following?
Oh, thank you. Are you running it locally too?
Hello?
Yeah, I'm asking if you're also running the codes locally.
No.
Okay. All right. Fine.
Okay, let me
Please,
share.
Mr. Sam, you have the floor once again.
Okay, this one. Okay, so once we created our model, we need to compile it. So to compile a model, we take the very same name that we have used here, and let's say my model dot compile, my model dot compile, and we need to use an optimizer. So in optimizer, we will explain later. There are many optimizers. Well, now let's not explain this now. Let me explain it to you sometime later. So we're going to use the optimizer called Atom, and we're also going to use a loss function we have just learned about today. And the loss function we're going to use, it is a sparse categorical cross entropy, sparse categorical cross entropy. That's fine. And along with the optimizer and the loss function, we also need some metrics. The one we're going to use today is the, guess what? Accuracy. So just just a, just a review. First, we create the model with as many layers as we want. As long as the first layer is a flattened layer, then we can add as many dense layers as we want. Not exactly as many, but we can add lots of them. Then the final layer is an output layer with the number of neurons that we are going to classify. After creating the model, we're going to compile the model. We're going to compile the model, and we need to use at least three parameters. An optimizer function, we're going to call Adam. We need a loss function. For this one, we're going to use sparse categorical cross entropy. And we need some metrics. And for this one, we're going to use accuracy. I usually like to write it like this. Let me run it, see if it is okay. It's not okay. Optimizer, it's not okay. Optimizer. Let's see it again. Okay, now it is okay. Let me share it with you. Good. Now what? We have created the model. We have compiled the model. Please remember these steps. Create a model. In fact, first acquire the data, split the data, create a model, then compile the model. And the next step, guess what? We need to train it. What is the keyword for training in machine learning? Can anyone let me know what the word for training is in machine learning? Hello? What is the word that we use to train our model? Fit. Yes,
Fitting.
so let's fit
Fit.
the model.
Fit them.
And you, by now, should know that fit a model is like taking a list, for example, a list of images and a list of labels. And we are going to try to fit the list of images with the fit of labels so that our model learns how to classify each of these items. This is what we call machine learning or deep learning. Okay, so to fit the model, it is something quite simple. We just call our model. In this case, it is my model dot fit. And as I said, we need to fit training images with training labels. So let's get the right word to avoid misspelling. So we need to get training images. We need to get training images and training labels. We're gonna fit images over labels. That's what we're gonna do. And we're gonna do that for, let's say, for 10 times. In times here we call epochs. So we're gonna train our model for 10 epochs. What means we're gonna train it for 10 times. So let's do it now. Oh no, let me share with you. So here we go. Let's train our model. Can you see, guys? It is in the first epoch. It has trained once and the accuracy was 76% with a loss of 4.0. The second epoch, the accuracy was better. Now it is 81. Now let's see the third epoch. Can you see that the more the model trains, the more accuracy we have. So, has it finished? Oh gosh, it should have finished. Let's see. Yes, it has finally finished. So we have one, two, three, 10 epochs. So can anyone tell me what was the accuracy in the first epoch? 0.76. And what was
0.763.
the final accuracy in epoch 10? Sorry?
0.8487.
What is it?
In epoch 10, we have the final accuracy is
Okay,
0.8487.
0.84. So it means that it is for 84% right. It means that if we try to guess what an image is, it will give the right answer about 8 out of 10 times. Two other times we will have a mistake, a false positive. Okay, so this is important to understand, as Josh has had explained earlier, that a model may not be perfect, but I can assure you guys that the more layers we add and the more techniques we add, the more accuracy we are gonna have. Okay, so let's try it. Let's see if our model is really intelligent, so to say. But before we do that, no, let me finish this. Let's evaluate our model. So now that our model has been trained, let's evaluate the model. So evaluate the model. To evaluate the model, we are gonna use a different set of images. Can anyone tell me what image sets we're gonna use now? Test, that's right.
Test.
So I'm gonna say my model, my model dot evaluate, my model dot evaluate. Evaluate what? Evaluate test images with test labels. As easy as pie. Oh, as easy as apple pie. Good. So, what am I telling my model to do here? I'm saying, hey model, you have read my images 10 times. What is the keyword that tells my model to read it, to train it X times? Can anyone remember? What is the parameter, the keyword that we use to say how long, how many times the model will train? Epochs, good. So now I say, hey model,
Epochs.
I have trained you 10 times. You have viewed, you have analyzed my images, you have tried to fit images over labels 10 times. And now I want to see how good you are. And when I say model.evaluate, I'm saying here are some images that you have never seen. I want to know how good you are. I want to know how big your loss function is and how big your accuracy is with images that you have never seen. Please note that there are two different things. We have training accuracy, it is a number, and we have evaluation accuracy, it is a number. The best word The bad thing that happens that should be is they are very similar, not very different one from other. So if we have about 85% of accuracy in training, we should have about 84, 82% in test, in evaluation. So now that we have done this, let me share with you. Let's run it. Whoa, what we see? We see that the evaluation accuracy is 81 and the train accuracy was 84. Is that any good, guys? Or is that bad? Should we say our training is performing okay, or do you think it is overfitting or underfitting?
If we compare accuracy, the accuracy of tested model is little lower than what we got in training model, training
Yes.
set. And the loss is
Okay. So
0.56.
for now,
So
sorry.
this one is telling us is underfit. It's underfitting. I think it's telling us it's underfitting. Since the Are you
Sorry,
with me?
I could not understand it. Can you rephrase that?
Hello, can you hear me? The question you ask is maybe it's overfitting or underfitting. So I
So
want
should we say,
clarification on
is
that.
it okay or not? It is okay. Yeah,
It's
it is
okay
okay, but it
because
could
this
be
one is not too
better.
much.
Okay, it is okay, but it could be better. But for now,
Okay.
it is, as it is our very first model, we should say it is performing okay. It is about 80% correct. We have 80% accuracy, and the validation accuracy is not so different from the training accuracy. So it means it is neither overfeeding nor underfeeding, probably not. So far it is okay. So to make sure it is okay, let's now test it. So let's now show a new, let's make a prediction indeed. Okay, let's make a prediction. So, come here. Now it is time to predict, predict. That's it. So to predict something, I'm gonna create a new variable. I'm gonna call it classification. Classification. It could be any name, right? I'm gonna call it my classification. So my classification, and my classification is gonna call my model dot. What is the keyword to do predictions? Can anyone guess? Predict.
Sorry,
Yeah.
Mr. Sam,
So
before
Predict,
you
the
go
keyword to
further,
predict
predict.
is
sorry.
predict. Predict. So easy, right? So to predict, I'm gonna use test images. So I'm gonna call it. So I have passed the test images, but before we go to the test images, what is the test image? Can anyone remember? Let's see, what type of uh, object is this? This is. test images is a NumPy array. Test images is a NumPy array. And we created it here, right? When we split the fashion MNIST data set. So what we're gonna do is we are going to show to our model the whole test images, and it's gonna do some predictions. So let's take one. Dawn, can anyone remember how big is the test images? If not, let's see. Lan, 10,000?
6,000.
Yes, it is 10,000.
6,000.
So there are 10,000 images. And with a simple click like this, my classification equals my model.predict, we have predicted all those 10,000 images. How can we know how good that was? We can print it. We can print. Let's print the first image. Let's see. What can we say? We can say something like print. We can say something like print. Let's say, does anyone know what slash backwards n means? Yes, slash backward
It
n
means a new
means new
line.
line. Okay, so let's create two new lines. Let's say classification, then let's say classification as remember we have just created this variable here, my classification. So let's use it, my classification, and let's take the first item, classification index 0. Let's add two more lines. And then let's take the label 0. Let's see. So my classification item 0, comma, test label 0. Is it okay? Test label should be okay. Oh, it is in the pool. Oh, it is okay now. Do you know how I guessed there was something wrong? Can anyone know if there is anything wrong with this line? Please have a look. Test label. It is there is an underline. It is underlined, okay? It means the system does not recognize this variable. So the right word is test labels. Oh, now okay. So whenever you see in a red like underline, it means that the system does not recognize that variable, and probably that variable does not exist in memory. So As I saw that, I knew that the right variable was not test label, but indeed test labels. Now it is okay. So what I'm going to do now, I'm going to run this. I'm going to call the classification. I'm going to call the classification variable, my classification variable. I took the item, the first item, which is item 0, and I said, my classification, please print the probability list of items. And let me explain it to you. Do you remember how many items there are in the fashion, distinct items they are in the fashion model data set? Can anyone tell me? No, no,
60,000.
distinct, unique.
60,000.
How many unique files, articles are there? Does anyone remember? That's good. Let's learn one thing. Let's take the LAN test labels. LAN test labels. I'm gonna show you something very important. If I run this, we're gonna find 10,000 labels. I wanna know, I wanna know how many distinct. I want to know how many distinct, unique items in the test labels. Before we do that, let's see the type of test label. So type test labels. Labels. It is a NumPy array, okay? So it is a NumPy array with 10,000 items. I want to know, I want to take only the distinct, the unique items. To do that, I'm going to create a variable. I'm going to call it my unique items. My unique items equals set test labels. And let's show it. Oh, here they are. So what have I done? I have converted the NumPy array into a set. And just for you guys to remember, Python objects. Python objects. We have strings, we have numbers, there are strings, there are numbers, there are lists. For example, there are dictionary, and there are sets. Let's see the difference between these three, quite important, okay? So, oh, like this. When I tell you all the time, please learn Python, this is what you need to know. You don't need to learn mathematics, you need to learn Python. So, a string is my string. This is my string. I love Python. I love Python. Oh gosh. I love Python. This is a string, right? So let me see its type. So type my string. Oh, not mice. Okay, like this. It is a string, right? So let's create a number. Well, let's create a float number. So let's say my float number. I just need to say what happens if I just say 5? Is that gonna be a float or an integer? Please help me. Is my float number a float number or an integer? Can anyone help me? It is an integer, right? Let's
Integer.
show it. It is an integer, okay? To make it a float, I just need to add dot. So let's now try it. My float number, oh, now it is a float number. So this is the way we create a float number in Python, okay? So this is my float number, and this is this is my integer integer number. My integer number, let's see its type. It is an integer, okay? Now let's create a list. Let's call it my list. And in my list, we're gonna have house. Let's see. Oh, sorry, I wrote it in Portuguese. House. Then we're gonna have another house. Then we're gonna have a building. Let's check what this is. Type my list. It is a list, okay? So if I print it, let me just say my list. We're gonna have everything there: house, house, and build. Let's create a dictionary. So my my dictionary. So a dictionary has a key and oh, a key. I always forgot. Sorry, house. Let's see what type it is. It is a dictionary. In the dictionary, I can also duplicate it. That's why I'm gonna show you the difference. So it is still a dictionary, and I'm gonna print it. Dictionary. One house and one house. Okay. So a dictionary is, how is a dictionary different from a list? Can anyone know? Let me know.
Hello. A dictionary is a key value pair. Why a list can uh, a dictionary is a key value pair. Why a list is just an array of number
Good. That's
or
it.
elements.
Thank you. Let's see what this this one is, if I did it right. Oh, type. See, a tube is like a collection of strings, but the difference between a tube and a string is that in a tube, tuple, sorry, in a tuple, we cannot modify a tuple. A tuple is like a constant, okay? And the last one that I'm gonna show you is, I'm not gonna tell you what, I'm gonna just call it x equal, oh, I have just said it. So my set house and house. So what's wrong here? Oh, sorry. Set house. Let's see if we multiply. Just a second. Let's see if I got it wrong. So let's see the type. Type. So guys, the difference between a set and a tube and a list is that a set does not accept duplication. So when I wrote my set house and house, when I call it, all I have are a split of all the words with no repetition. So in a set, there are no repetition. So why do we need to know that? Because right now, we were trying to understand how many different distinct items there are in the test labels. And to do that, all we had to do was like, what is it? This. We converted the test labels into a set, and instead of taking 10,000 items, it returned just 10 distinct items. So this is the very difference between set, lists, dictionaries, tupes, strings, integer, and numbers. This was just a very brief review, but it is very important to master this. Otherwise, you're gonna have trouble, a hard time trying to run your code. Any questions here, guys, before we go to the next and final step?
Yes, please. I think Fatu actually was asking if you could explain the train fits part of this
If we could
model
explain
building
what?
again, please. Where
Oh,
we
the training
trained the
session.
model, the training session
Yeah.
of the model.
We
If
train
you
the
could
model with
explain
this
it.
word. This is how we train
Yes,
it.
please.
Fit.
Yes.
Fit is the keyword. Fit means train. Okay? Fit means train. In machine learning, okay? And to fit a model, usually, but not always, but usually all we need is two variables. like training images and training labels. Then we are going to try to understand the relationship between images and labels. This is what we call train. This is how we have trained the model. And we have trained this model for 10 times. We said train it for 10 times. How many times can I train the model? Well, it is up to me. It depends on the quality of the data that I have. If I have very good data, high quality data, I may train my model for just 3 or 4 times. If I have very bad data, I may need to train this model for 20 times, 20 times, 30 times, 40 times. It all depends. And what is the right number of times we need to train our model? In other words, what is the right number of epochs we need to train it? There is no right number. You need to analyze your data, you need to train it, see how accuracy is. If it is not as good as you want, you may add some more epochs, you may add some augmentation, something that we're going to see next class. You may add some dropouts. These are some other things that we are going to see next class. Have I answered your question, Fatou? Good. So let's review the pipeline,
Yes.
the pipeline, machine learning, deep learning pipeline. Okay. So let's review it together. So here, let's call this one what? Import libraries. Import libraries. So here we have imported our libraries. Then we have acquire, acquire, acquire data. Not sure if you are familiar with this word acquire. Let me write it. Get data. So first thing we do is import libraries. Done. Then we have acquired the data. This is what we did here. Then we split the data. Split data. We usually split in training and validation or test. So then we split the data. This is what we did here. We have split the data. Then what else we did? We analyzed the data. Analyze the data. This is what we did here. We understood the length. We showed the images, so we analyzed the data. Then what else have we done? Then we create the model. This is number 5, right? Then we create the model. After creating the model, we compile the model. Then we train the model. After training the model, we evaluate the model. After evaluating the model, if everything is okay, we need to make no more adjustments, then it is time to predict the model, make predictions. Oh, there is something that I have not showed you. But before we finish, we are about to finish today's class. So let me just make sure we have all the phases here. So this is it. Import the model, acquire data, split the data, analyze the data, create the model, compile the model, train the model, evaluate the model, make predictions. This is the way we go with no matter if it is deep learning or machine learning. These are very common steps. Okay? Any questions so far?
Hello, my question is on that prediction.
Oh, good.
Mm,
Let
prediction.
me show you the prediction.
I didn't get
So,
it
in
very
the
well.
prediction, what have we done? After we have created and evaluated our model and trained the model, create, fit, and evaluated the model, we did some predictions. What have we done here? Uh, we just said my model dot predict, and we passed as the parameter a list of images, a list of images. And for every images, and remember in this case, in this data set, there are 10,000 images. We just said my model, please predict what each of the 10,000 images may be. And once it did this, and it is very fast for 10,000, see it, just about 2 seconds. In about 2 seconds, it predicted 10,000 images. It is time for me to go back to, oh, sorry. When we predict, we created a variable called my classification. And this classification, let me show you what it is. The classification, it is numpy any dimensional array, okay? Let me write it. NumPy, NumPy, any means many dimensional array. This is what this object is. So this is a NumPy any dimensional array. And what it is, well, it is just a list of images. It has image one, it's in a probability of classification. Let me show you one of these probabilities. It has 10,000 items. No, not this one. Let me show this one. My classification. Let's see its length. As just like the main array, it has 10,000 items. Let's see what we have in any items. Let's see my classification item 0. So for item 0 in this classification, this is the only information that we have. But before we go, let's have a 5 minutes break, okay? This is the final step, but I need some water. So let's give it a 5 minute break. And when we come, I will explain it. What we have here, this is a probability. Uh, I will explain how to understand it and how the classification works, and then we will be done for today. So a 5 minute break. Is that okay? Okay, we'll be back.
Yeah, sure. Thank
Good.
you very
We
much.
are back in five
Yes,
minutes.
yes, yes, it's okay.
Okay.
Yes, yes.
Cool. So, guys, do you also want to go on break or we just interact for the 5 minutes?
Anyone?
We can interact.
Yeah, sure. So how is it going at your end, running the notebook locally?
I've been able to honor the notebook, and it's giving
Oh,
me the same
interesting.
as we got from the. Though I do have some
Interesting.
challenges, like the last one, the question I go back to, so I miss it while he was running it, so I couldn't get
Oh,
the classification, the predict model very well. So as I asked to ask him again so I can explain, and I think I am
oh,
getting it better now.
oh, okay, 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 cool then. I really must commend you all that are actively participating in the class. It's encouraging and it's it's keeps us. It's like a drive that keeps us to continue this session. Thank you all. For whatever reason today, Versha has been silent. Alice, Alice,
Me, I'm still with you. Are you?
yeah, sure.
Okay.
Alice, how is it going at your end?
Quite good.
Interesting.
Yeah, I'm following while coding at
Awesome.
the same time.
Oh, awesome. Awesome. So you're also running it locally at your end.
Yeah, yes, I am.
Interesting. Interesting. Good to hear. Good to hear. How about Fato? Please pardon me if I'm murdering your name. It's not intentional. Fato, Fato, how is it going at your end? You're mute if you're talking. Okay. Hello.
Hello.
Yes, hello. Hi. Good evening or whatever. Good day. How's it going at your end?
Yeah, it's going quite well. I've been doing the exercises and I'm still following too.
Awesome. 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 Are you running
Mm.
the notebook locally too?
No, not currently. Now I'm just watching this session. I'll try and do it on my own.
Cool. Kevin, what's up at your end? Hello, Kevin.
Yes,
Yeah.
yes. Sorry, I didn't get that.
Okay, I'm asking, how's it going at your end?
Okay, it's going on well. Actually, I was actually doing the codes together, but after some while, I decided to follow it up so that I can understand fast what is going on.
Okay. Okay. That means you definitely would go through the recording, right?
Yes, yes, yes.
Cool. Cool.
Hi guys, I'm back.
Cool. Um, so, Mr. Sam, if you're back, you might want to continue. Otherwise, yeah.
Hi, can we go on?
Yeah, so I'm asking if you're back, if you're ready to continue. Otherwise, we can
Yes, you're
still
with you.
Yeah,
just continue with
if
our
you're
chit.
talking to me, yes, I'm ready.
Okay, cool
Okay,
then. So you
thank
have
you
the
too.
floor.
Well,
Thank you.
so Remember, when I said my classification equals my model dot predict test images, it took those 10,000 images and made a prediction for each one of those 10,000 images. And for each of them, it created a probability distribution for each of them. So if I print my classification and take the very first item, it returns a probability distribution. Sorry for that. So it returns a probability distribution for every one of those 10 items. And what it says, hey, I think that for the first item, the probability that it is the first item, it is 2.7 something. For the second item, item number one, because it begins with zero, right? It is an array. For item number one, the probability it is 7.5 something. And remember, it is our scientific notation. It is very important to understand this, okay? And it goes on for every one of those 10 possible items that we had in the test labels. So in the test labels, we had 10 unique distinct items. So for every one of those 10,000 items, it, it returned a probability distribution that one specific item belongs to that specific class. And which class is does this belong? Well, it is the class with the highest probability. But how do we read that? This is why I asked you in the group if you were able to know from those 10 items which one is the biggest. And you don't need to learn mathematics, as I said. To take the highest distribution, what we're gonna do is that we are gonna take, instead of printing the probability distribution, what we're gonna do is, let's see if I have imported NumPy. Yes, I have imported NumPy. So what we're gonna do is, instead of just saying my classification 0, we're gonna say print numpy dot argmax, and this function will return the item with the highest probability. So I say print numpy, let me copy this, argmax, then I pass the classification item. So if I do this, it says, hey, the classification, the item with the highest classification is the item number 7. So 0, 1, 2, 3, 4, 5, 6, 7. Is it any easy to answer that? Do I really need to call nep.arg max? Yes, because we can automate this. We are going to automate this answer. But if you want to just have a look at, just look for the item with the smallest scientific notation. And this is it. E E01. So 10 to minus 1, it means 10 to minus 1. So the smaller is the number after this 10, the bigger the number is. So the the item numbers, the classification item number 0 is probably what? I don't know what a classification item is. Let me see here. Oh, uh, here. So let's see. Zero, 1, 2, 3, 4, 5, 6, 7. It is a sneaker. So classification item number 0 is probably a sneaker. But how probable is that? Well, it says it is about 51% probable that that is a sneaker. This is the answer we have. So how can we know that? Well, we can call NumPy, sorry, we can call matplotlib and show it. So let's do it. Let me uh, do one thing here. So let's call NumPy and let's see if it is okay. Classification, where are you? Oh, it is here. So let's say plt dot em show test image item 0. Oh, is it test? It's not test, right? plt dot im show test, isn't it test images? Let's see. Oh, test images in plural. Oh, so it got it right. Item number 7, and let me call it from here. Item number 7 is, oh, let's do this one here. Let's just copy this one. I don't want this. I want item number 0. So item number 0 is an ankle boot, and it says that it belongs to the class, to the 7th class, right? So let's take the list of classes here. So 0, 1, 2, 3, 4, 5, 6, 7. The 7th class is indeed a sneaker. So the prediction was correct. Let's see here. Ankle boot. It is indeed an ankle boot, so it got it right. Please let me know if you got it, guys. If not, I can explain it again. Okay,
Please come
so
again. Please come again.
has anyone understood it? If so, is there anyone that could explain instead of me? In other words, no? Okay, let me go again.
Do I go? Okay,
Would anyone like
fine.
would anyone like to talk? No? Okay.
Okay, to explain the prediction
Okay,
part,
so
right?
let
Is that
would you like to go on, please? Oh, okay, good. Okay.
you can continue, please?
So
Thank you.
before we go on, let's review the pipeline, the whole pipeline. So first thing we did, we imported the libraries. Then we got data, we acquired the data. Then we split the data in We split the data in training and test. So we have training images and training labels. We had test images and test labels. We use the training images to train the model. And then to evaluate the model, we use the test images. It means data that my model has never seen. We are going to evaluate how good it is working with data that it has never seen. This is what we did in the split data. And then we analyze the data, just showing the images, how many items we have, and so on. Just a visual analysis, okay? After that, we create the model. We create the model with three layers. A flattened layer that will take a three-dimensional array and make it a one-dimensional array. A second layer that we call an input layer that will take as many neurons as I say. For example, in this case, we said, okay, work with 512 neurons to analyze the data and try to learn the relationship between training images and training labels. And once you complete, go to the final layer that has, it is a classification layer, it is an output layer. So that's what we did in the model creation. After we create a model, we need to compile the model. We compile the model, we name the optimizer, the loss function, and the metrics. And after we compile the model, it is time to train. And to train a data, it is as simple as saying, hey, my model, please fit the training images over the training labels. And please do that for 10 times. 10 times means 10 epochs. Okay? Just repeating. My model, please fit means train the data, fitting the training images over the training labels. Repeat that 10 times. This is how we have trained our model. Okay, so far? Is that okay? Are you there, guys? Good.
Yeah, we can hear you.
Good.
Yes,
So
it's okay.
after we train the
Yes, that is
model,
okay.
in the variable called my model that we have created earlier, we have all the mathematical algorithm that is able to evaluate and also to classify new images. So when we say my model dot fit dot training images over training labels, what happens here, guys, is a lot of mathematical functions, derivatives, integrals, trying to get the best model and the relationship between images and labels. And we store that information in a variable that we called my model. It could be, again, Varsher, it could be Josh, it could be Sam. I called it my model. Okay, that information is here. It means all the intelligence of the model, now it is in this variable. And now that we have a variable, in, let's say, an intelligent variable called my model, we can call this variable to evaluate, I mean, to look at images that it had never seen before, which are the test images, and see how good it is. And we just say my model dot evaluate test images over test labels. Remember, my model had never seen test images nor test labels. And once it did it, it said, okay, I have evaluated 10,000 images and I was 81% good. It means accuracy 0.81. So it was really good. It was not the best one. It could be 95, it could be 98. But so far, it is our very first model. It is good so far. It worked okay. Okay? So we have evaluated. And once we evaluate it, we say, okay, now it is time that you evaluate uh, evaluate some other models. We have split this data into training, test, and validation. Sorry, we have split only in training and tests. Sometimes we split it in three parts: training, validation, and tests. It is okay so far. We have split it only into two parts, training and tests. And what I say now with this line is, hey, my model, please predict all those. Let me write it here. Hey, my my model, please predict those 10,000 images in the in the test image array. This is what I'm saying. Then, after you make any prediction, store the probability, probability distribution of each item in the my classification variable. That's what it did. So this is what this line does. Hey, my model, please predict those 10,000 images in the test image array, then store the probability distribution of each item in the my classification variable. My classification variable. And this is what it did. So now I can call my classification. I can see that my classification has 10,000 items. I can see that what? Let's see. Type my classification. My classification is a NumPy any dimensional array, and it has 10,000 items, and each item, it is like this. This is item number 0. It is a probability distribution. Let's see. Item 0, the first one. For the item 0, the first item, what we have is a probability distribution. Probability distribution for each of the 10 unique items. It means, okay, I have seen those 10 items, and for each one it says the probability in percentage. So for item 0, it says this is the probability. And please remember, it is a as it is a probability distribution, it goes from 0 to 1. Any of this number is between 0 and 1. As these numbers may be very small, they are represented in a in a in a scientific notation, using scientific notation. So again, now I want someone to answer me. What does it mean? Oh, let's take this one. Um, okay, what does it mean? Let's take this first number means this. Oh, sorry. Give me a second. Yeah. Okay. So this first number is a number that is really, really, really small. It is the number, it is 2.72 times 10 to minus 34. So it is a very, very tiny number. So is there any probability that the first item that we are looking at here, it is item number one? No, the probability is very, very, very small. So which item is item number one, this one that we are seeing here? Oh, it is probably, we're gonna take with this function we call numpy.argmax, then we pass the item, my classification item 0, and they will return a number. If I run this, it said, okay, the highest number that you have in this array is the item number 7. 0, 1, 2, 3, 4, 5, 6, 7. This is the most probable classification that we could find. And for item number 7, the classification is an equal good. And in fact, it is an equal good. So that's it. This is how it classified. It will never say, hey, this is an ankle boot, or this is a pullover, or this is a sneaker. It is always going to say, well, there is a probability X that it is a sneaker. There is a probability X plus Y that it is a pullover. There is a probability X, Y, Z that it is a coat. Then you take the one with the highest probability and use it and say, okay, my model says that you are a coat. And remember, my model is not perfect. The accuracy was only 84%. So sometimes there will be an error. It will have a false positive. It will say it is a coat, but it may be a sneaker. What can we do? We can improve this model with some other techniques that we are going to see in the next class, called convolutional neural network. There are two other techniques to complete the whole data processing. In fact, there are three other techniques, but I don't know if I will have enough time. But at least for next week, we're going to cover convolutional neural network and data augmentation and dropout and callback. There are four other techniques to improve the way a model works. But for now, my question is, was it any clear now, or do you have any other questions?
It's clear.
Yes, it is clear. We will study later also, and we will go through it
Good.
once
So what I'm
again
gonna
at
do,
our
I'm gonna
end.
share this notebook with you, the whole notebook with you. Okay, let me do it right now. So save. Guys, the difference among between studying with me and Josh here is that if you go to the online classes, you will not see the details that you see here. It supposes that you know scientific notations. It supposes that you know how to get images, how to work uh, with sets, with lists, with dictionaries. This is how different this class is. So let's go. Okay, so the notebook is available at GitHub. Please see the address. And that's it for today. I hope you liked it. I hope it could give you some more information. Let me stop this one.
Yes, it's an interesting class, and we get a lot from it. Thank you.
Okay,
Thank you